Alrighty, here is 7-3, day 3, okay? Again, it has the theme that we're going to take on a couple new little wrinkles on solving trig functions. This is it, by the way, 7-3. It doesn't have multiple parts like the first two. There'll be a fair amount of content in here, but it's doable to do it in a single lesson, okay? But specifically when we say translated trig equations, right in there, right? We've seen this number before, b, that we know for a trig function controls the period, okay? We're going to look at solving trig functions where we have a value for b, because if you look back through all your notes, we haven't done that. We've done a lot of different stuff. Solving trig equations, we haven't done that, okay? That's what today is all about. All right, so b is what we call a coefficient of x. In other words, the number that goes right in front of it. If b is greater than 1, the function compresses, meaning there are more solutions than normal, okay? If b is greater than 1, right, and for normal, we typically expect 2. But if b is bigger than 1, know that that number is going to go up. If b is between 0 and 1, then the function stretches, and we're going to get fewer solutions than normal. Now, when we're doing this, same deal. Get your trig term isolated. Take the inverse so we get bx by itself, right? I'll talk about that when we get to some examples. That's really like nothing different, right? Your trig term, do the inverse. Instead of basically just having x or theta by itself, b is with it. Okay, so we just have to figure out, okay, to get our final answers, how do we handle b? Unit circle will come up, as always. Those answers have to be exact. This part's a little bit tricky, okay? Tricky to explain. You'll see it when we do the example. If b is bigger than 1, find b number of coterminal answers to step 2. In other words, if b is 3, do 3 coterminals. That's what it's saying, okay? If b is 3, do a coterminal to get 3 answers. If b is 4, do 4. And the very, very last thing is we deal with b and have to divide by it to get theta or x, right? We're kind of using those interchangeably here. That just know that that's the variable we're solving for. Could call it theta, could call it x. Doesn't really matter, okay? That's a description of the process. Let's do it. 2 cosine 3 theta plus 1. Let's dive right in. Well, before that, let's just check Mo here. Look, we got 4 examples total. We're in radians the whole lesson, okay? And some of these will be on the calculator. These first 2 won't. I think only the last one will. But well, the others go to the unit circle, so we're talking radians. All right, trig term by itself. Add 1. No different. Divide by 2, right? We're getting the trig term by itself. Cosine of 3 theta equals a half, right? Cosine of 3 theta equals a half. Okay. We do the inverse. Okay? So 3 theta would be cosine inverse of a half. Right, this is the same that we've done before, except instead of theta being by itself, we've got a 3 with it, which is fine. Just go with it. For now, we're just gonna carry the 3 along, okay? And if I go to the unit circle, I would find 2 spots. where cosine is a half. Pi over 3, 5 pi over 3, okay? This is the part where we get into that coterminal thing, okay? So coterminals, I can add 2 pi, right? So I'm looking at this saying I can add 6 pi over 3. I got the denominator of 3, so that's what I want to add. Add 6 pi once. Add it again. And from there, stop, okay? How did I know to stop there? B is 3, okay? I did the coterminal twice, so I have how many answers? 3, okay? So and this only comes up if B is greater than 1, right? And that's the case here because I recognize right away B is 3, okay? B is 3. So do the coterminal until you have 3 answers. Same thing down here, 11 pi over 6. Excuse me, over 3. And 17 pi over 3, right? Each time I do it until I get 3 of them. All right, we got to get rid of that 3, so let's do this. Multiply this side by a third. Same thing here. And here's what we're going to get. These are my final answers now. I'm kind of going right in order, starting here. Pi over 3 times 1/3. Pi over 9. These are final answers, by the way. I'm down on the bottom row now, 5 pi over 9. 11 pi over 9. 17 pi over 9. Okay? And done. Okay? All done with that one. We normally get 2 answers. We got 6, right? You might look at that. Like, is that a thing because B was 3 and 2 times 3 is 6? That is very much a thing. As to what, if you pay attention to B, the bigger B is, the more answers you're going to get. Because B was 3, we got 6 answers. All right, really not going to see anything different on this one, right? I noticed right away B is 4. Okay, which tells me I am expecting, if this is similar to the last one, I think we're getting 8 answers, okay? We're going to get 8 answers total. All right, so we'll add 2. Cosecant of 4 theta is 2. No, thank you. I'll take sine 4 theta is a half. Time for the inverse. So 4 theta equals inverse sine of a half. I go to the unit circle, and I get 2 scenarios, right? This is kind of, so I do the inverse. This is kind of where like I'm getting my 2 answers. I go to the unit circle and see, okay, pi over 6, 5 pi over 6, right? If there was no 4 there, we'd be done, right? That's a really good way to look at this. If there was no 4 with the theta, we're done. We have our 2 answers, okay? We got to deal with that 4, okay? First thing we have to deal with is we need to add 12 pi over 6, right? For each one of these, I want to get 4 answers. 13 pi over 6, 25 pi over 6, 37 pi over 6, and I stop because I've got my 4. $17 pi over 6, 29 pi over 6, 41 pi over 6, right? Just on that, just all that's going on. Once I got the right denominator of 6, and I'm writing 2 pi is 12 pi over 6, all I'm doing is on the coefficient up on the top, I'm just adding 12, right? In both cases, that's all I was doing. Just keep adding 12 to the top. Once I got 4 each, I'm done. This is kind of where I take these two and I bring them together. The whole thing needs to be multiplied by a fourth, just because to get final answers, that 4 with theta needs to go away. So I multiply it by a fourth, right? Those are gone. And now, I mean, I'll rip through these pretty quick, because all that's going to happen, if you look at what's going on with multiplying by 1/4, they have a denominator of 6. That denominator is going to switch to 24. That's all that's going to happen. Okay, you're multiplying by 1 on the top. Okay, so I'm going to start with the first set of solutions. Pi over 24. 13 pi over 24. 25 pi over 24. And how about 37 pi over 24? Again, you might be thinking, slow down. Way too fast. all I'm doing is switching the denominator to 24, right? I go down to the bottom here. I've got 5 pi, 17 pi, 29 pi, 41 pi, right? Those 4. All over 6, switch the 6 to 24, and you're good to go. Five pi over 24, 17 pi over 24, 29 pi over 24, and how about 41 pi? Okay. Now you might look at that and think, geez, okay, yikes. Remember what we said on the first slide? The bigger B gets, the more answers we get, right? And we're kind of pushing the issue there, right? Because if we made B 5, we'd get 10 answers. If we made it 6, we'd get 12, right? I don't think we'd go much over 4, right? You'd expect to see B equal to 2, 3, and 4 quite a bit. That's kind of what I plan on, the kind of problems that I'd assign for you on homework. Right? So I want you to mess around with B, but I don't want you to go crazy. All right, so this one is a little bit of a different deal, okay, from the others. B is a half. It is less than 1, okay? So this whole thing of like our function being compressed and getting lots of answers, that's not going to happen, okay? That's not going to happen. All right, 3 tangent of 1/2 x equals square root 3. Right? All I'm doing is isolating my trig function. Tangent of 1/2 x, right? At this point, I would say I've got it isolated, is square root 3 over 3. Okay? Once we have our trig term isolated, inverse. Whoops, I don't want to write it this way. Over here, I want to put 1/2 x, and then on the right side, we need to do the tangent inverse of square root 3 over 3. Okay? Now don't get the variable name in this problem is x instead of theta. Don't worry about that, right? That's just the unknown that we're solving for. A lot of times we call it theta because that's a common variable name for a missing angle. You don't have to call it that. Okay. We're on the unit circle. Okay? We're on the unit circle. We've got pi over 6. we've got 7 pi over 6. Okay, those are 2. Now, the whole like, oh, hey, go add the coterminal to get more answers. B is less than 1. It's not a thing on this problem, okay? We don't do it. All we actually end up doing here is we're going to multiply by 2. Okay, you're basically just getting to the point where you got to address getting rid of this 1/2. Right? So I'll multiply that by 2, that by 2. And I get x equals 2 pi over 6. Right? 2 pi over 6 is pi over 3. That's an answer right there. Okay? Let's do the same thing down here. Multiply it by 2. 14 pi over 6. Okay? That can be reduced because both are divisible by 2. 7 pi over 3. Now, this is really sneaky. Really sneaky. Especially when you're dealing with exact answers. You kind of want to box that one up and say, hey, we're good to go, except we only give answers up to 2 pi. So, I mean, mathematically, to say it's a solution isn't wrong, right? You could, I mean, a solution in the sense that if you wanted to go back to your original equation, and if you want to plug 7 pi over 3 in there, and then multiply it by 1/2, then take its tangent value, and then multiply it by 3, and then subtract square root of 3, you're going to get 0, okay? But we only give answers up to 2 pi. So I would expect on that one that you recognize, wait a minute, that one is too big. We're not going to give it as our answer. Only one answer, right? So it's interesting when b is less than 1, the graph would get stretched out. And you actually go from 2 answers down to just getting 1, right? If you think about the previous 2 examples, it kind of makes sense. When b was big, we compressed the graph, we got more solutions. When b is small, we stretch the graph out, we got fewer. Okay, and when I'm saying more or fewer, I'm starting as 2 as like our baseline, right? That's kind of our note. We expect to get 2. But because b was small, here we only got 1. All right, only new piece here is this one is going to take us to our calculator. Divide by 5. Cosine 3 theta equals negative 2/5. Okay. Time for an inverse, right? Our trig function, all we had to do is divide by 5, and we got that by itself. So we'll do 3 theta. And I probably should have recognized this right away. This is back to the case that we saw in the first 2, because b is 3, which is bigger than 1. So I'm thinking big picture right here. Answers. What am I expecting? 6, right? I'm expecting to get 6. Unless something goes really weird and, you know, I don't know what happens. But if all goes according to plan, I'm expecting to get 6. All right. Cosine inverse of negative 2/5. Okay. Here's our 2 cases. Okay. Case number 1. Now this is a little bit different because we're not going to the unit circle, so we have to remember our rule for the other one. Right? So the calculator is going to give you 1.98, right? Rounded to the 100th, we're talking radians, right? 1.98. Case number 2, 2 pi minus 1.98, which will equal 4.30. Okay? 2 pi minus our first gives us our second. And again, I think just to relate it back to what we've done, I like to kind of pause here for a minute to emphasize if we didn't have the 3, we're done, okay? If we didn't have the 3, we'd have our 2 answers like we've seen so many times before, okay? But we do have the 3. And so like from the math side of it, like you should look at that and be like, well, just multiply both sides by a third and we're done. Yes, except because the graph is compressed, right? We get these additional solutions. I got to set us up to get those first. Okay, we're talking decimals right now. So we add 2 pi, so I got to add 6.28. $8.26 and 14.54. 4.3, 10.58, 16.86. Okay. Again, to get those 4 extra solutions, all I did is add 2 pi approximately. I added 6.28. B is 3, so I stopped once I had 3 of them. Now we're good to go. We've addressed the fact that we're really going to get 6 solutions. So if you multiply by a third, really what's going on here is each of these 6 numbers need to be divided by 3. That's all we got to do. 1.98 divided by 3 would give you 0.66. Okay? $8.26 divided by 3, 7.25. I'm not worried about them having in number order. I just want to get all 6 solutions. 14.54 divided by 3, 4.85. 4.3 divided by 3, 1.43. 10.58 divided by 3 would be 3.53. And 16.86 divided by 3 would be 5.62. There's our 6 solutions. Okay? There they are. So you had 4 good examples in there, right? Again, the whole theme on those problems is what if B, right? A parameter that we've seen before, controls the period of the graph. We talked about B a lot when we were doing graphing. What do we do if B isn't 1? That's what this lesson was all about.